Alright, so we're going to continue on with section 3.2 today, continuing talking about limits graphically and numerically. We are going to discuss the formal definition of a limit, sort of, understand one-sided limits, and continue to practice evaluating limits numerically and graphically. So the big thing we're going to add on tonight is the one-sided limit. So here is the notation. The limit as x approaches c from the left of f of x, or the limit as x approaches c from the right of f of x. So if you see as what looks like where we would put an exponent, a little minus sign or a little plus sign, that says that you are approaching c from the left if it's a minus sign, and from the right if it's a plus sign. So remember, you are approaching it from that side. So if you're approaching from the left, you are actually moving to the right. If you're approaching from the right, you're actually moving to the left. Okay, here's the theorem about the existence of a limit. This is in your book. It's Theorem 3.8. That's why you can tell this is just a copy and paste. But let f be a function and let c and l be real numbers. The limit of f of x as x approaches c is L if and only if the limit as x approaches c from the left of f of x is L, and the limit as x approaches c from the right of f of x is L. So in general, what this means is what I talked about earlier today in class, and that is for a limit to exist, the function needs to be approaching the same value from the left and from the right. So when you're evaluating a limit, you have to check from both sides. So here, let's evaluate the limit as x goes to 2 from the left of the absolute value of x minus 2 over x minus 2, the limit as x goes to 2 from the right of the absolute value of x minus 2 over x minus 2, and the limit as x goes to 2 of the absolute value of x minus 2 over x minus 2. So basically, this one down here, the limit as x goes to 2 of the absolute value of x minus 2 over x minus 2 is just saying check from the left and check from the right. If they're the same, then that's your answer. If they are different, then the limit won't exist. So we're going to use our calculator here, so I'm going to put this function in. And we want math. Alright, so let's look at this graphically. So here I can see graphically that as the function approaches 2 from the left, the height of the function is approaching -1. So the limit as x goes to 2 from the left is -1. I can see the limit as x goes to 2 from the right is +1. So the limit as x goes to 2 from the right is 1. Since those are not the same thing, this does not exist. Alright, so now I want you to look at the limit as x goes to 2 of f of x when f of x is x squared plus 1 when x is when x is less than 2, and -1/2 x plus 6 when x is greater than 2. So I want you to evaluate this limit. Pause the video, unpause when you're ready to check your work. Alright, so what we want to do here is look at the limit as x goes to 2 from the left of the function, which turns out to be 5, and the limit as x goes to 2 from the right of the function is also 5. So how I went about doing that is I used my calculator again to look at this graphically, and I also looked at the table. So here I can see the graph. I put in the piecewise function. Remember how to do that? So I did x squared plus 1 in parentheses, and then x is less than 2, and then plus the other piece of the function, which was -0.5x plus 6 in parentheses, and then parentheses x is greater than 2. So that's how I can see the graph here. It appears that as x approaches 2, these are going to the same height. Maybe from this graph it's a little bit difficult to see exactly what that height is, so that's why I used the table to confirm. So I approached 2 from the left, so 1.9, 1.99, 1.999, these values appear to be getting very close to 5. At 2, the function actually does not exist. And then here I approach 2 from the right. Again, these values appear to be getting very close to 5. So since it's approaching 5 from the left and from the right, the limit as x goes to 2 of f of x is 5. Alright, the formal definition of a limit, we are not actually going to talk about it. You can read it in the book if you want. It makes the limit sound very confusing, so I don't want to waste your time with it and confuse you and have you panic, which some of you tend to do sometimes. That's okay. But I'm trying to avoid that panic. So if you would like, for your own pleasure, you can read it. It talks about epsilons and deltas. And if you think about it, it actually makes sense, but it is more confusing than we need to do in order to understand limits. So, moving on. I want you to find the limit as x goes to 2 of 3x plus 2. Pause the video, unpause when you're ready to check your work. Alright, hopefully you got 8. Now we can get this by using our calculator again, so I put the function in, 3x plus 2. I can look at the graph. Again, the graph's not great, but you can use the graph, or I can look at the table, and I conveniently already have these numbers already typed in from the previous problem. So as I approach 2 from the left and as I approach 2 from the right, the values appear to be going towards 8, and at 2, the value is 8. So in this case, and this is kind of leading into what we'll get to in two sections, I believe. Maybe it's the next section, but since we know what this graph looks like, this is the equation of a line, and a line is continuous everywhere, so there's not any holes or asymptotes or anything that would cause a limit to not exist. So as I approach 2 from the left, it's actually going to be what the value is when x is 2. So 3 times 2 is 6, 6 plus 2 is 8. Alright, last one. I want you to use this graph on the right. We can assume that goes on forever, that goes on forever in that direction, and I want you to evaluate the following on the page. So pause the video, use that graph, and evaluate all of these problems. Unpause when you're ready to check your work. Okay, so I tried to kind of color code this so you can follow. The limit as x goes to -4 is -3. I can see that down here. That is where the function exists at -4, and it's continuous from the left and the right. So as I approach from the left and as I approach from the right, the y value is approaching -3. The limit as x goes to -4 from the left is -3 as well. That had to be true since we found this already. The limit as x goes to 0. So x is 0 right here. So as I approach from the left and as I approach from the right, the y value is -1. The limit as x goes to -3. As I approach from the left, the y value is -4, but there's nothing from the right. So the limit does not exist. The limit as x goes to 1 is right here. As I approach from the left, that's 0. As I approach from the right, that's 0. So the limit is 0. The limit as x goes to -3 from the left. Well, we just talked about this up here. The limit as I go to -3 from the left is -4. So since it's a one-sided limit, it does have an answer. The limit as x goes to -1 does not exist. Because as I approach from the left, it's 0. There is nothing from the right. The limit as x goes to -1 from the right. I'm sorry, I misspoke. As I approach from the left, there's nothing. As I approach from the right, it's 0. So for the previous one, and therefore that leads us to this, the limit as x goes to -1 from the right is 0. What is f of -4? So remember, this is not a limit now. This is saying what is the function value at -4. The function value at -4 is -3. What is the function value at -1? The function value at -1 does not exist. Now, I want to point out, let's say that the function value had existed. So let's say that was a filled-in circle here. F of -1 would have been 0, but the limit as x goes to -1 would still not exist, because from both sides it would still be approaching nothing. Alright, so same conclusion from earlier today. The limit is what is the y value or height approaching at a given x value. We need to look from both the left and the right. It has to be approaching the same height from the left and the right. The function does not have to exist at that point, but the function needs to be approaching the same y value from the left and the right. We also just talked about the notation for one-sided limits, so we need to make sure we understand that notation, that when we see the limit as x goes to c from the left, that is not saying negative c. That's saying c from the left. Alright? See you tomorrow.